On the free response, usually, so question 1 will always be a graphical display question, no matter what, on the free response. It'll either be a question from Unit 1 or 2, which we will accomplish very early on. We did Part A for that free response. Part B asked you to describe the graph or to comment on it. And there are 2 ways that we can comment. If you have a categorical graph, like we did on the free response from last class, then you discuss in certain words frequently or infrequently occurring categories. So what that means, if you have one set of data, you might want to write this to this side. If you have one set of data, you are simply going to list the frequencies of each category. It's kind of boring. So I think, what is an example we did last time? Talking about the number of letters, and well, that was numerical data. What is the category? We did the ice cream flavor one. So we had vanilla, chocolate, strawberry, other. So to describe that, you could combine this into maybe 2 sentences, or you could do it as 4 sentences. Whatever you want to do, but you could say 4 people prefer vanilla, comma, 3 people, and this gets boring, prefer chocolate, ... I watched that clip last night because I was just thinking about it, and I YouTubed it and watched it. And then I got into this long list of the funniest moments of SpongeBob, and I just was dying laughing. Anyway. So, for categorical, if you have one set of data, then you just list out the categories and tell me. You're just explaining the graph in your own words. If you have 2 sets of data, you compare, I'm going to underline this word. Compare the 2 samples. So usually it's like male and female within each category. Now, compare words. And the reason I'm so picky about this is because while is not a compare word. So if you said 40% of males prefer vanilla, while 30% of females prefer vanilla, while is not a comparison, and they will not give you credit for it. So comparison words: less, greater, higher, lower, more, etc. They have to indicate a direction in which you're comparing the 2 categories. So you could say more males prefer vanilla than females. More. That's my comparison word. So you're going to go through category by category, and you're going to compare the 2 groups of people. If there is no comparison, you get an I. So if we go back to that free response, we would want to compare the males and females in every category. So that's going to be your homework tonight, or part of your homework, is doing part B of that free response. So you're going to take each category, and you're going to compare the one that says man earns more. Which one had a higher frequency? Which one? I don't know what the other options were.
Does it matter if there's more males than females?
No. You're just simply stating the facts. You're not commenting on them. So let's look at, there's an example of a double bar chart in here. Here we go. Let's talk about, so we've got 4 categories. Let's try to create or comment on this graph that we see right here. If you want to write it down, you can. If you don't want to, then let's just audibly talk about it. So I'm going to take the first category.
parents than students like less than 250 miles.
Right, so I could say more parents prefer students to stay close to home. More parents prefer less than 250 miles than students, yes.
So you base it off the relative frequency,
Mhm. Not the actual number. Yeah, so you're going to base it off the relative frequencies.
Because then more students would everything. Yeah, I know.
Right.
Wouldn't you have to say that a higher frequency of parents? Because,
It's higher relative frequency because, like decimal, because if we go back to the slide before that, there were like 12,000 students and 3,000 parents. So just looking at the numbers themselves, it's going to look like there's more students than parents in every category.
Okay, so just saying more parents prefer to students is okay?
Like you could say a higher proportion of parents, higher relative frequency. Just indicate that you're talking about the percentage versus the number itself. From 250 to 500 miles, you could say that they're about the same.
Is about as many comparison.
Yeah.
You found
Approximately equal. You could say
What if you said?
approximately is our favorite word in this class.
What if you said it's about an equal compromise between 250 and 500 miles between the parents and
Oh, that's
children?
fine. So then 500 to 1,000 is a higher proportion of students than parents for 500 to 1,000 and 1,000 plus. You could even combine these two to be one sentence if you wanted.
More students, more freedom.
This is not rocket science, but I will say, especially by the end of the year, this is one of the one of the easiest things to forget because you do so many more things after this. So we try to stick it in our brain now. Hopefully we will not forget. So for categorical data, you're just listing the categories. If there's two sets of data, you compare. How to describe a numerical graph? We will. Hold on, let me get this ready. We will cuss.
We will cuss. Cuss.
We will cuss. Say it with me. We will cuss. We will cuss. That's it. That's all I have.
That's fine. Good talk.
Thank you. Okay. What the C stands for is center.
Center.
So here we have three graphs, A, B, and C.
Okay.
What strikes you as the most distinctive difference among the three?
They're on different floors.
They only look the same.
That one's supposed to hit the center, but the PowerPoint got a little messed up.
I
Their
think
centers are different, okay? So we talk about the first sentence. We're going to have 4 sentences in every description. The first sentence we're going to discuss the center. That could include mean, median, or mode. In this unit, because we don't really use our calculator that much, we haven't learned how to calculate the average on the calculator. I know you probably know how, but just for this unit's sake, most commonly we use the median. So your first sentence could be, if we were talking about the letters in our name, what did we think the median was about? It looked like, I think it was 7. 5 or 7, I don't remember.
it was 6. There we go.
The median number of letters in a name is 6. So that would be my first sentence. The median number of letters in the first name is 6. That's my first sentence.
That's exciting.
You specify what the median is. That's center. Next letter, we are not going to do U. We're going to save that one for last. But in order to call it cuss, the U has to go second. Look at this. These 3 distributions, what looks like, so they all have the same center, but now what's different about them?
They're spread out.
Spread out. So we call it the spread. That's the first S. Spread.
Spread.
Spread refers to the variability in the data. You can either report the range, the standard deviation, or the IQR. We don't know how to calculate the standard deviation or the IQR yet.
So we do
So
range.
we're going to use range. What is range?
Least to the least.
Max minus min. Is your range one number or two numbers? One number. The range is one number.
One.
Put that down.
Whoa, really?
You wouldn't say that it ranges from 2 to 5. That's incorrect. You would say the range is 3. So, who had the smallest number of letters? I had 10.
The smallest was like 4.
4. So 10 minus 4 is 6. So we would say the range number of letters is 6.
The range is 6.
So it's just
And-
minus smallest.
The
Mhm.
median number is
And this does not need to be a fancy paragraph. It doesn't need to make a whole lot of grammatical sense. Don't fluff it up. Don't try to fluff it up. I don't want you to. The median is this. The range is this. The next S.
shape.
How did you know that?
Us.
So, the shapes are different. I wish that PowerPoint were better, but it's not. The next is shape.
Us.
Whoa. So we have a couple of options. We could say it's approximately symmetrical. That word approximately is my best friend because it's not exactly symmetrical. So we just say it's approximately symmetrical. It could be skewed to the right, skewed to the left. It could be uniform or bimodal. So let's go through and say what each one is. Symmetrical, when it's like if a bell shape, you could even use the word bell shape if you want. But if you folded it in half, it would be equal. It'd be symmetrical. Okay, the next one is uniform. That's when you have equal frequency all the way across. So, while uniform is also symmetrical, it just looks like a box. So the reason why there's a bunch of soldiers here is because they're wearing a uniform and they're all like the same height. That's why they do that. Equal frequency. So an example of a uniform distribution is if I were rolling a dice, my options are 1, 2, 3, 4, 5, and 6, right? That's the only options of results that I could get when I'm rolling a dice. And they all have an equal chance of being selected. So every side of that dice has an equal probability. So if I rolled a dice 100 times, a die? A singles die? Okay, that's fine. So if I did that 100 times or 60 times, then you would hope that there would be 10 on each number. Is that better for you? So you would hope that they would all have an equal amount. Now that may not necessarily be true, but we would call that a uniform distribution. The next one is skewed.
Whoa.
The directions are either right or left, and whichever one has the longest tail. So a right skew is going to look like this. This is right. A left skew is going to look like this. Just whichever way the tail goes. A lot of times the AP test will consist of scenarios in which you have to decide what type of distribution it is. Like, would it be a right skew? Would it be a left skew? So we're going to have a lot of practice of reading a scenario and deciding the shape of what that would be.
It's a right skew.
I don't like that. No, I don't like it.
It's a bell shape.
Okay, do y'all have this example? Okay, I'm going to skip it. The last one is bimodal. Bimodal is when you have multiple peaks. Or two peaks. Multimodal is when you have multiple peaks. So an example of a bimodal, the best way that I can describe that is like when I am measuring the heights of people that shape would be approximately, so if I took a sample of 100 girls, then the heights would be approximately symmetrical because you have, or shoe size even. The average shoe size is probably around a 7 or so. Then you have some that are a little higher, some that are a little lower than that. And then if I were to find the average shoe size for men, then I don't know what that shoe size would be, like 10 and a half, 10, I don't know. And then some higher, some lower. So if I were to gather data all together and I took a sample of 500 people at PCA, men and women combined, then my graph is probably going to look something like this, where it's going to be centered around 7 and centered around 10. Because you have a high frequency of girls here, a high frequency of boys here. So that would be an example of a bimodal, where you have 2 peaks.
You need 2 categories to have a bimodal.
No, you don't, but that's just one example.
Can a bimodal be symmetrical?
Yes.
So it can be a bimodal.
Mm-hmm. Mm-hmm. Bimodal distributions can occur when the data set consists of observations from 2 different kinds of individuals. So that's kind of the example that I just gave. Okay, last thing. This is the U. The U stands for unusual occurrences. So we talk about outliers, gaps, or clusters. Outliers are just values that lie away from the rest of the data. Now, we don't know how to mathematically calculate an outlier yet. You weren't here on the first day, but we don't talk while I'm talking. Outliers, we don't know how to calculate those mathematically yet. But for now, you can just look at a graph and decide if it has an outlier or not and just comment on that. If there are no outliers, you can either say there are no outliers or you don't have to write a sentence at all. It's up to you. Gaps are when you have spaces in the graph, and then clusters is when you have high frequency at a particular cluster.
So you said we don't have comment on it?
If you don't have any of these 3 things, like if they do not exist, then you don't have to comment.
But if they do,
You do, yeah.
So if you had a, like,
Yeah, can you show us an
bimodal,
example?
would you
That's
consider the 2 peaks to be clusters? Then you would have to comment about that.
No, you wouldn't have to because you've already talked about bimodal. But if you wanted to, you could. It never hurts to talk about it, to write more than less.
When you
Can you draw us a cluster, please?
So a cluster would be if you had high frequency here at, I don't know, what's an example of data that we could collect? 7. What is the 7 about? Ours.
Favorite number.
7 hours.
Favorite number. Everyone's favorite number is 7, and then my favorite number is 13. So here you could talk, you have a couple options. You could say there's an outlier at 13.
Or you could say there's high.
You could say there's a gap between 7 and 13, or you could say there's a cluster at 7, and any 3 of those would be sufficient.
What if
No.
you said all of them? Extra credit?
No, there's no extra credit.
Don't waste your time. Don't waste.
Also, the last thing is in context. So we must cuss, but we must cuss in
Cuss.
context. What it means to be in context
To be quoting someone.
is that you have to
I'm sorry, I didn't say a word.
you have to talk about what your problem is referring to. So in the example that we were going with, it was number of letters in your first name. You have to reference that in some form or fashion. You cannot say the median is 6, range is 6, no outliers, shape is symmetrical. That would get you no credit because I have no idea what you're talking about. So you need to say the median number of letters in the first name is 6. From there, you've given me your context, and then you can just quote the rest. So it needs to be about the subject of the problem or the content.
Can we only write about stuff there is, so if there's no clusters or gaps or outliers?
You don't have to write it. Mm-mm. Okay. The last thing, so that was with one set of data. I want to find us 2 sets of data. Is there a graph on here that has 2 sets of data?
Yes, after continuous system.
Okay, let's go to this one. So here is,
Right there.
here we go. It's not showing up on my iPad. There we go. Okay, that was with one set of data, you give the numbers. So I'm going to do this for a second. One set of data, use numbers, like use the values, the actual values. When you have two sets of data or more, you don't use numbers. You can, but you don't have to. But comparative language. So you're going to compare the medians. You're going to compare the range. Compare median and range. Then you can't really compare the shapes, so you'll just list the two shapes and list the outliers. So compare the two medians. So let's look at, after you write this down, we'll go back to those two graphs and we'll look at which one has a higher median or which one has a lower median, which one has a larger range, smaller range, like that. Yes?
So this fussing thing is only for the numerical
Mhm.
graphs, and then the other thing where we just like write like there are more people like red than green.
It's for categorical. Perfect.
But you
Yes.
don't use them both.
Mm-mm. No, because you'll either have one or the other. So you first have to identify, is this categorical data or numerical data? From there, then you decide how to comment on it. So here we have length of hours spent watching TV per day. And we have two comparative histograms. You can either, like if you were to draw comparative histograms, they would either be side by side or you could stack them vertically, one on top of the other. But they need to have the same scale. So you'll notice that they have the same scale so that you can accurately compare them. Because if one had a different scale, it would look differently. Yes. Just a rule of thumb if I ever ask you to create comparative graphs. So let's talk about it. If we're looking at the median, I know it's kind of hard to count, but which one would you say has a higher median? Age 1 or age 3? Age 1 probably has a larger median. So age 1 has a larger median. Length of hours, remember my context. Length of hours spent watching TV per day. You write all that out. Then we compare the range. So max minus min. What about their ranges? They're exactly the same. So you could say both age 1 and age 3 have the same range.
So you don't have to use numbers.
Mm-mm. You can always add numbers in, but you don't need them, and sometimes they get confusing. So what ends up happening, and this is why I say no numbers, is because people would say the median for age 1 is 7 hours, while median for age 3 is 4 hours, and that is not comparative. So you would get 0 points for that. Because even though you told me both medians, you're just telling them you're not comparing them. If you wrote this and then you said, therefore, which is too much writing, age 1 has a larger median, then that would be okay. It's just unnecessary. You don't need all of that.
So you could just be like, the median for
'Cause
each one is longer.
This word right here is the point earner is the word larger.
Wait, so for the range, are they the same because there's values at 0 to 16?
So 16 minus 0 is 16.
So what type of graph is it where you just subtract the two?
That is what you're doing.
Um,
Max is
They
6.
go the exact same.
The max is 16.
It doesn't matter.
And then a 0.
It just matters if they're in number.
Right. So if my graph stopped here at 4, then my range would be 12.
Okay.
It just so happens that they both hit the 0 and the 16. Okay, so we did the range. What about the shapes? Shapes.
They're both
Skewed left.
That's right.
Right.
Whitley.
So you could say both graphs are skewed right, or both distributions are skewed right. It's a big fancy word.
I want to say both graphs are skewed right.
Once we get more mature, we'll start using the word distribution.
What is
Distribution.
I haven't found that yet.
And you could say there are no outliers, or you could just leave it be. I would just say leave it be.
Those kids watching 16 hours.
I'm going to record this. Here's my soapbox about income. And this is kind of the way that you have to change your brain to think when you're reading these. Income, you cannot have a negative income. So like your graph will always start at 0 when you're talking about making money or even time, the time it takes to do something. You always start at 0. So my minimum will always be here. But with income, you can always make more money. So you could have somebody that made 500 million. And those would be outliers. So you're going to have some high outliers. But everyone's probably going to be here from 0 to 200. That's where like almost everyone will probably be. Then you've got some outliers that are out to the right. Okay? So you're always going to have really high outliers when it comes to income. And also, if I were to change this to, I think that one of the examples, I don't know if it's in here, like the amount of time, I think that's the last one, amount of time that you spend on the computer, distance, things like that, these will always be right skewed because you have to think about, you can't be less than 0, but you can always keep adding more. So, theoretically. Okay, what's the next one? Color. Color, because you don't have a shape for any categorical. So any categorical ones, go ahead and cross through those because you don't have shapes.
Categorical is my favorite.
I think the categorical has like histogram or things like that.
And the number of heads tossed.
for numerical.
If you stop there, that bar
You do. The number of heads tossed. So we only do the shape.
Okay, so with number of heads tossed, when 4 coins are tossed simultaneously, so if I have my graph, I'm either going to get 0, 1, 2, 3, or 4.
Be that box.
Right? Where do I think that most of them are going to fall?
Uniform.
2.
It's a bell.
shapes the bell.
Beautiful. So it's going to be approximately symmetrical because I would expect that 2 out of the 4 would be heads. So I'm going to have the highest frequency at 2. I won't have very many that get 0 heads or 4.
What do we write?
You can write bell-shaped.
Come back.
Number of speeding tickets.
Skewed right.
Skewed right.
If it's left skewed, that means you're.
Skewed right because most people are going to get anywhere from 0 to 2. Then you might have somebody that is a speed demon and they get 10. Outliers. The distance you drive in one day. What did we say that is? Right. Does that logic make sense to you guys?
I'm learning so
Okay. Just checking.
I'm learning to explore.
Favorite movie type, that's going to be an X because it's categorical. Area code is an X, categorical. Okay. Number of correct answers on an easy 10-question true-false quiz. Left. Because it's easy. He'll be the outlier. Okay. Amount of time you spend on the computer.
Right.
Right.